Hi guys, so in the last video we used vectors and cosine similarity, so I'm going to explain what those concepts are. So basically there are two concepts. I'm going to explain vectorization and cosine similarity. So vectorization means turning the real world stuff like the sentences that we speak or use into a list of numbers. So why we do this is to be able to compare those vectors together instead of sentences. We can't compare sentences, how similar one sentence is to another directly, so we change those to vectors, right? So computer can understand and we can perform mathematical functions on them. So the reasons could be like even more vast. For example, you can find the similarity between sentences, you can find related documents, articles, you get these recommendation systems, your shopping list, etc. using vectors. You have search engines, Google uses vectors obviously, chatbots can use vectors to find customers queries, etc. You can make any kind of project using vectors. Once you can learn to convert the real world into a mathematical you can say representation, right? So today I'm gonna use a very simple vectorization method. This will be based on counting the words, number of words used in a sentence. So let's say I want to create a 4 length vector using these words only. So I'm gonna first make an index for these words. I will be represented by 0th index of the vector, and love will be on the first index, pizza will be on the second index, and hate is on the third index. So I love pizza. To convert this sentence into a vector, what I can do is write each of these count for these words, right? So 1110 will represent this sentence in a 4 length vector, right? And if I want to add a hate word, then it will be represented 1011. So I have converted these two sentences into vectors, and now I can run a function or now we have these mathematical representations of these, so we can run our mathematical functions, cosine similarities, to find how similar these two sentences are, and we can also create a different. So this is the simplest form of vectorization I've used here, but the thing is that you can I have used OpenAI vectorization as well, embeddings in the last video you can check out. So there are different types of vectorization processes. This is just based on counts. This is very simple. This won't provide you real value. So there are different type of vectorization processes that give more weights to different words, or they can also set up context based vectorization. So each word has its context of previous word and the next word, that will make it more complex. So these numbers can go very high or very low, and the length of vector can go above 1000 or could be in thousands, right? And some also give value to grammar. Some vectorization process give value to grammar of the sentence and the meaning of the sentence. This can become very complex actually. More rare words can hold more weight. So this is the simplest type of vectorization. You don't need to learn that complex processes for this course. We can just continue with this for now. For understanding, this is fine. And then we have to compare two vectors, right? So now we have used, in the previous video I used cosine similarity from sklearn to find the similarities between those, right? So this function cosine similarity, this basically just finds the cosine similarity is basically just finding the angle between two vectors, and if the angle is 0, the similarity is 1. So these are very highly related vectors. And if the angle is 180, it's like opposite, the arrow is opposite to the first arrow, then they are very opposite, and they are not similar, they are actually opposite. And 90-degree angle means that there is nothing similar to both of these sentences or vectors. So this is what cosine similarity does, just based on the angle between those two vectors in a 2 dimension, right? Multiple dimensions, sorry, it's not bound to 2 dimensions. This is how these two methods work together for understanding, but we don't actually have to implement these are already implemented by data libraries, so we can just use those libraries directly and get our results and create our apps or systems, right? See you in the next video, guys. So I'll try to implement a perplexity type of perplexity type of project, mini Google search, right, with the in GPT API. So please like and subscribe so I can continue making these videos. Thank you.